Okay, we come to the last part of the video for today's asynchronous lecture. We're still on the derivative, and we are going to touch on the theorem of the derivative. Okay, the theorem says if f, or the function fx here, is differentiable at a maknanya at the point x equals to a, then confirm fx ni is continuous at x equals to a. Okay, what is continuous? Remember, we have learned at the last part of chapter 2, and basically you may, kalau tak ingat dah, tiba-tiba je, and for the direct intake especially, you're not really sure apa maksud continuous ni, please refer to my asynchronous lecture last week, week number 5, okay? So, okay, remember a function to be continuous, dia kena make sure it satisfies three condition kan. Fx tu exist, limit fx, okay, fa at x equals to a, as x approaching a tu pun exist, and then first condition kena sama dengan second condition, then we can only say the function is continuous kan. Alright, so kat sini, kalau function tu differentiable, confirm it is continuous. For example, we have a continuous curve like this. Okay, kita tahu the function tu as long as there is no breaking point, dia akan sentiasa continuous kan. So, kalau you tengok ni, dia memang continuous. So, confirm this function, this function is differentiable. Okay, sorry, dia terbalik. Kalau function tu differentiable, okay, maksudnya it is continuous. Bukan function tu continuous then confirm it is differentiable. Bukannya dia kena kalau function tu differentiable, maknanya confirm lah the function tu continuous like this, tak ada breaking point apa. Tapi kalau function tu continuous, dia tak confirm lagi that the function is differentiable. Okay, kalau function tu continuous everywhere, dia tak guarantee lagi that it is differentiable kat mana-mana pun. Okay, so for an example, let's have a look at this example 3 kan. We have the function fx equals to modulus x. Kita dah discuss about this modulus function, where it can be this kita break out into 2 for x more than 0 and x less than 0 kan. So saya draw dulu sekejap fx ni. So we have fx here and this is x. The graph is equals to x for x more than 0, not equals to 0 ya. For more than 0 is equals the graph is equals to x kan. Semua orang tahu kot graph y equals to x kan, dia is a straight line with this dengan keturunan yang menaik. Okay, and then x less than, ni kat sini 0, and x less than 0 is equals to negative x, just like a mirror. Okay, so this is x, this is negative x kan. Okay, so this is y equals to negative x, and ni pula y equals to x. Okay, so you all semua tahu this is the equation y equals to x and y equals to negative x, right? So daripada sini kan, sebenarnya we can find its slope, betul? Okay, the slope y equals to x ni, okay, apa dia punya keturunan? Kita tahu kan the formula y equals to mx plus c. Tengok macam ni pun kita tahu the slope of this graph is equals to 1. And y equals to negative x pula, dia punya slope is equals to negative 1. So for your information, m equals to negative 1, m equals to 1 ni lah sebenarnya the derivative of x. Okay, the derivative of negative x is negative 1. Tak percaya? Okay, so kalau you tak percaya, then you may try to find the derivative of fx using the definition, not yet the formula, sebab formula kita tak discuss lagi. We're going to discuss soon, very soon, after we have completed this slide. Okay, this theorem. Alright, so kalau tak percaya kan, we have a function fx equals to x. Nak cari dia punya derivative f prime x, like what we have done before, limit h approaching 0 f x plus h minus with fx over h kan. So kita punya x plus h kita ganti je lah dengan h approaching 0 ni. X plus x ni kita ganti dengan x plus h minus with fx kita adalah x over h. Okay, over h. So nampak kita cancelkan negative x dengan x. So we have h over h. H over h samalah dengan 1. So samalah dengan yang ni. So f prime x for x more than 0. Kita boleh consider graph ni. This is x. This is f prime x. Dia untuk x more than 0. Dia tak include 0 ya. So more than 0. So is equals to 1. Ni 1. So is equals to 1. Tapi x equals to 0. Dia tak include because it's more than 0. F prime x sekarang ni is equals to 1 for x more than 0. For x more than 0. Sebenarnya at x equals to 0 is not defined. Okay. And then for negative x, kita dah cari pun sebenarnya m is equals to negative 1. Tapi kalau you tak puas hati, tak apa. You can find it as well. Okay, you may find it as well. Okay, beza dia sekarang ni, kita punya ni adalah negative x kan. Sekejap adalah negative x. Okay, kita punya ni adalah negative x. Tak nak keluar pula ink ni. Okay, negative x. Oops, sorry. Is equals to negative x. So, kita gantikan dia dengan limit h approaching 0, negative x plus h. Okay, gantikan x tu with x plus h, negatif kat luar, and negative x kita, fx kita adalah negative x over h. Okay, over h. So what you have over here is limit h approaching 0, negative x, negative h, negative x ni, minus x, you're gonna have plus x over h. So negative x plus with x, you will get 0. So we have negative h over h. So nampak tak? Kita dapat negative 1. Samalah dengan slope yang you tengok daripada this graph straight away. So maknanya kat sini negative 1 f prime x is equals to negative 1 for x less than 0. So again, less than 0. It does not include 0. So nampak? So, from here, from this graph, what shall we conclude for the value f prime 0? Ada tak value for f prime 0? It's berlubang here. And in fact, the limit kalau you check limit from the left of f prime x, limit from the left of f prime x is equals to negative 1. Limit from the right from the right tak sama dengan negative 1, but it's equals to 1. F prime x ya, bukan fx. And then you see dekat f0, f prime 0 is berlubang here, meaning that f prime 0 does not exist. F prime 0 does not exist. So kalau f prime 0 does not exist, maksudnya it is not differentiable at x equals to 0. At x equals to 0, the function is not differentiable. Okay, the function is not differentiable at f prime at x equals to 0. F prime x, okay, is not differentiable at x equals to 0. Okay, f prime 0 here does not exist. Okay, f prime 0 does not exist. Ni bukan maksud dia ni. F prime 0 does not exist at x equals to 0. Walaupun hakikatnya, kalau you tengok graph of fx ni yang kita dah discuss tadi, it is continuous at x equals to 0. Tak ada apa. It's defined at x equals to 0 for the graph fx. Okay, however, when you work out and find its derivative, you can see f prime 0 does not exist. So, moral of the story, walaupun function tu continuous, it does not guarantee that it is differentiable. Okay, tapi kalau function tu is differentiable, then confirm the function is continuous. Alright. Okay, so in conclusion, okay, jawapan kepada yang ni tadi kan. Okay, sorry kan. Jawapan kepada where is the function f(x) is differentiable, maksudnya it is differentiable. It is differentiable everywhere lah. Except at x equals to 0. Ataupun you boleh cakap it is not differentiable at x equals to 0. Kenapa? Saya dah explain tadi kan. Alright. Next, in conclusion, how can a function fail to be differentiable? Yang ni yang kita discuss tadi. Yang the graph tadi. Kan, fx kita nampak tak bentuk dia? Dia tajam. Dia ada bocor tajam kat sini. Okay, samalah dengan pattern yang saya tunjuk dekat graf yang ni, yang A ni. Okay, where we call this condition, penyakit dia ni is a corner or king dipanggil. Okay, when the function macam A ni, graf ni kalau tengok, there's no breaking point, it's continuous. However, it is not differentiable at x equals to h because samalah condition dengan fx equals to modulus x tadi, because we have a corner or a king point at x equals to 0 ni, it is not differentiable. Okay, so reason dia sama dengan yang saya discuss just now. And B, confirm lah if the function is discontinuous. Okay, dia kata the function is only kalau function tu differentiable, it is continuous. So maknanya kalau function tu tak continuous, confirm it is not differentiable. Okay, and the third case, if it is a vertical tangent line, macam graph ni kan, we have, nampak kan, the dotted line ni is our tangent line. Kalau you try to cari the slope of this vertical line, dapat tak cari slope of the vertical line? Apa slope vertical line? That slope vertical line itulah sebenarnya the derivative of fx at x equals to h kan. Okay, kalau the slope of this vertical line maknanya dia sharing the same value of x ke y. Katakanlah kat sini kita ada point let's say at this point kita ada y equals to 4 lah, and another point here. Okay, point A, point B, and this is y equals to 1. So point A kita, ni x ni, maknanya nampak tak? X kita, we are sharing the same value of x. Katakanlah kat sini x equals to 1. So point A kita adalah 1, 4. Point B kita adalah 1, 1. So macam mana nak cari slope of this tangent line? M is equals to apa? Y kita, point Y kita 4 tolak 1. And however, the point x kita sama. We have a common value of x because this is a vertical line. So we're going to have 1 minus 1. So we get what? 3 over 0. Exist ke tak 3 over 0? 3 over 0 ni is infinity. Right? 3 over 0 is infinity, where it is not a real number. So it is considered tak valid lah, okay, or you may say undefined ataupun does not exist juga sebab dia infinity. Okay, infinity ni bukan a value. Alright, so because of that, maksudnya the derivative of the function fx at x equals to h is not exist. Okay, or it does not differentiable for a vertical tangent line. Untuk case graph yang lebih kurang macam ni lah, when you get a vertical tangent line, maknanya it is not differentiable because you try to cari dia punya slope pun kita tak dapat a real number, kita dapat infinite punya derivative. Alright, okay, next. Okay, dan barulah sampai ke benda yang senang untuk you cari derivative here. Okay, we're going to end our synchronous lecture with this rules of differentiation. Okay, konsep dia kelas untuk you differentiate. Okay, we have the power rule here. Dia cakap kalau constant rule, if C is a real number, okay, is a real number maknanya nombor je. 3 ke 4 ke 5 ke whatever number it is, then its derivative is 0. Okay, kenapa 0? Because it is independent of x. 3, you differentiate 3. 3 ni sebenarnya adalah x kuasa kosong. Okay, x kuasa kosong. So kalau you 3 ni constant, you boleh letak 3 ni kat luar. D dx of x kuasa kosong. X kuasa kosong ni, differentiate ni, dia punya rules dia, formula dia adalah kosong. Bila you nak differentiate, kosong ni you you turunkan ke bawah. So you turunkan ke bawah, x kuasa dia you tolak 1. So negative x power of negative 1. Tapi tak payah nak consider power pun, sebab kosong whatever you multiply with, you will get 0. Okay, so that's why the derivative of a constant is equals to 0. Ataupun kita boleh kata is independent. 3 ni independent, dia tak bergantung kepada x. So definitely the derivative of 3 is 0. Ataupun satu lagi konsep, 3 ni kan is a garis lurus, horizontal line. And if you try to find the slope of the horizontal line, which is considered the derivative of this line, of course you get m equals to 0 kan. Itu is another reason why we get the derivative of a constant is equals to 0. Okay, so next, the second rule is the power rule, which is, I consider this as a very important rule. Okay, if n is a positive integer, d dx of x power of n, nak cari dia punya derivative senang sangat. Okay, make sure maknanya ni adalah alternatif kedua. Sebelum ni kita cari derivative using the definition yang guna limit tu kan. So now we come to the shortcut lah. The power ni kita turunkan ke bawah. So n ni turunkan ke bawah, x tu masih lagi ada lah. And the power will reduce by 1. n minus 1. For example, if you want to differentiate d dx of x power of 2, the simplest example, maknanya jawapan dia 2 kuasa kan turun ke bawah, x, then 2 tolak 1. So dia punya answer is 2 x power of 1, or just 2x lah. Okay, kalau d dx of x power of 5, maknanya sepantas kilat sekarang semua dah pandai kan. 5x to the power of 4. Macam tu je. Senang kan? Alright. Then we have extended power rule here. So maknanya n here ni, dia bukan sahaja kepada positif, negatif pun dia terpakai. Okay. Positif ke negatif ke dia terpakai. If for any integer, cakap kan. For any integer here is any integer. Maknanya kat sini d dx x power of n, katakanlah n kita adalah negatif kan, d dx x power of negative 5 for example. So maknanya dia punya formula negative 5 ni going down, x power of negative 5 ni careful ya, tolak 1. Tolak 1 dia bukan jadi negative 4 sebab kita negatif ni. So we're going to have negative 5 x power of negative 6. X power of negative 6. Okay, boleh faham Katakanlah kita kata d dx of x power of half. Half ni pun integer juga, 1/2. So dia punya answer will be 1/2 ni turun bawah, x power of 1/2 tolak 1. So we gonna have half x power of negative half. Okay, we will have more examples soon. Okay, and then it is mentioned constant multiple rule. So katakanlah kita ada a constant depan function tu. Okay, a constant depan function tu. For an example, d dx of 5x square. Ini buat macam mana? Worry not, 5 ni letak je kat luar because 5 ni kan independent of x, tak ada kaitan dengan x, letak je kat luar, bukan buang macam tu je. 5 d dx of x square. So what you will get here, 5 d dx of x square is times with, okay, 2 turun bawah x dan 2 tolak 1. So we get 5 ni boleh darab dengan 2 lah. 10 x power of 1 ataupun hanyalah 10x. Boleh faham tak? Okay, very simple kan? Katakanlah kita ada d dx of negative 10x power of half. Macam tu. So, negative 10 is a constant, bring it out. So, you have d dx of x power of half. So, ni adalah negative 10 ni masih lagi ada. 1/2 ni turun ke bawah. Lepas tu, x ni maknanya 1/2 tolak 1. Dia punya kuasa tu kan. Tolak 1, betul? Negative 2 dengan 5 ni, 10 ni boleh ganti. So, we have negative 5 x power of negative half. Inilah jawapan dia. Negative half kenapa? Sebab 1/2 tolak 1 tu. Alright. Okay. So, now we have the final example 4 here. Can we solve this quickly? Hopefully semua orang boleh faham dah sekarang. T kuasa 11. So, F prime T dia senang je lah. 11 turun bawah. T kuasa 10. That's it. Okay. GT. So, G prime T. So, maknanya GT ni juga sama dengan, kalau nampak macam complicated ni, 6 square root T ni sebenarnya adalah 6T kuasa 1/2. Betul? So, G prime T dia akan jadi 6 darab dengan 1/2. Kuasa ni kan turun bawah. T kuasa 1/2 tolak 1. Right. So, 6 dengan 1/2 jadi dapatlah 3. T kuasa 1/2 tolak 1 negatif half. Ataupun 3 over square root T macam ni. Tu adalah jawapan untuk B. Okay, now let's have a look untuk C pula. Okay, untuk C ni we have GT ni. GT ni pun sebenarnya sama dengan, kalau you nampak tak familiar macam payah je ni, kita naikkan atas semua. 3T square tambah 6. T power of 7 ni over T power of 7 maknanya T power of negative 7. Betul? So, G prime T, ni saya pergi laju sikit 2 ni kita turun bawah. Jadi 6. T ni, kuasa ni 2 tolak 1 jadi T power of 1. And 6 darab dengan negatif 7 ni. Tambah 6 darab dengan negatif 7. Darab je, bukan tolak. Ya. T kuasa negatif 7 tolak 1. So, at the end, you get 60 minus 42. T kuasa negatif 8. Ataupun kita boleh tulis 60 minus 42 T kuasa 8. Okay. That is the answer for C, G prime T. Okay. Next. Okay, next D ni. E the power of 3. Biasa tengok tak E the power of 3? Apa benda E power of 3 ni? E ni adalah exponential function. Okay, you boleh tengok dekat calculator. Okay, dekat calculator tu ada E ataupun this exp. This is considered as exponential. So, gx of e the power of 3, maknanya kat sini, untuk find g prime x, kita cari the derivative ddx of e the power of 3. Tengok, e the power of 3 ni sebenarnya is a constant. Kalau you cuba tekan calculator, e power of 1, you akan dapat value 0.7 something. Saya pun tak ingat dah berapa. Kalau e power of 3 maknanya ada value. Maknanya it's just a constant where it is independent of x. So, macam mana kita discuss the first rule tadi. If c is a real number or constant, then the derivative is equals to 0. So, yang ni kosong je jawapan dia. G prime X dia adalah kosong. Okay, G prime X dia adalah kosong. Okay, kelas. Untuk E, F dengan G ni saya, okay. Untuk E ni sangatlah senang. Okay, G prime W. Okay, dia punya ni adalah apa? 5/6, 12 ni kita darab. Kan, buat turun bawah darab. Dan W kuasa 11 lah. 12/1. So ni you akan dapat 2. So the answer will be 10 W power of 11. That's it. Very simple. So we have discussed A, B, C and tiba-tiba je E. D kat sini kat bawah ni tak perasan pula. D. Then we have E. Alright, for your last class word submission questions, very simple yang ni. Kalau faham maknanya 2 saat lah boleh jawab. 1 saat untuk F, 1 lagi saat untuk G. Ataupun maybe G ni 2 saat lah sebab dia square root S. Okay, so for another question to be submitted for class word submission, please solve F and G example 4 as well. Yang ni sangatlah kejap saja kan. We already have one question for class word submission. Soalan mana tadi? Soalan ni kan. Soalan number 2, example 2. Question number 2, example 4. Question E, F and G. Alright, I think that's all for today asynchronous lecture. Okay, we'll stop here. Thank you everyone. Assalamualaikum warahmatullahi wabarakatuh and bye-bye.